Again, I said take out a highlighter, or if you have a colored pencil or something with you, because I want you to use it. So just quick review. We kind of talked about this when we played our Kahoot on Tuesday. A function means that every X corresponds to only one Y value. So I want you to take your highlighter or colored pencil, and I want you to draw some vertical lines on this diagonal. So just as many as you want all over it, just draw some vertical lines. So by drawing these vertical lines, we can tell that this is a function. And the reason why it's a function is each of those vertical lines is only touching that diagonal one time. So for each line we draw, it's only touching it once. So the vertical lines only touch the graph once. And this is called the vertical line test. Again, something we have discussed before, but I did want to remind you a little bit about it. All right, so when I say linear, I mean straight line. So can you think of a straight line, a type of straight line that wouldn't be a function? So what kind of straight line would I touch it more than once? What? Well, a straight line is what I'm looking for. Yes, a curvy line could not be a function, but there's only one kind of straight line that's going to give us something that's not a function.
Vertical?
A vertical, yeah. So if I drew a vertical line, guess what happens when I try my vertical line test? How many places is it touching that vertical line? A lot, all of them, an infinite amount. So vertical lines are not functions. Also, functions don't have to be straight lines. Here is a line. Well, I'm not going to call it a line. Lines are straight. So when you say a line, you need to be talking about something that's a straight line. A curve, this is also a function. It's not a line, but it is a function, because if I take my highlighter, and I want you to do this, you can draw a bunch of vertical lines and it's not going to touch it more than one place at a time. Tough. All right, so what I want you to do is on number 1, if you flip the page, you're going to tell me if those are, which one's a function or not a function for each of those. And then on number 2, I want you to check off the ones that are functions. So for number 1, tell me if it's a function or not. And then number 2, just check the ones that are functions. I'll give you a second to do that.
Do we do the ones on the right side as well?
No, we're going to talk about those together.
All right, so.
Jackson, you have a lot of lights in that room happening.
Yes, ma'am. I can.
Can you change the color? That's so cool.
Yeah, I can change
LED.
colors.
They're not LED lights, they're LED lights. Okay, so for number one, I hope you drew a line, but you'll notice no matter what vertical line you draw, it's only going to touch that graph it's going to touch the graph more than once. So it's not a function. Number two, or the second one, although it looks like those lines are going to go vertical, they're not. It is a function. They're going to stay a little bit diagonal the whole time. For number two, the first one is a function. The second one is not because I touch it twice. The third one is not. Oh, no, I'm checking them. The third one is not. The fourth one we talked about, it's not vertical line. The fifth is, because I'm only touching once, the sixth, the seventh, and the eighth are all functions. So in the first row, only the first one, and the bottom row, all of them are functions. Okay, so we're listening. So raise your hand if you are 5'7". Just me? 5'7", 5'7" feet tall, yes.
I'm 6 foot.
Okay, so sure, we'll say you're 5'7". So Lance and I are both 5'7". Does that mean we're the same age? No. Okay, so I'm 30. Does that mean I'm 5'7"? Is every single 30-year-old in the whole world 5'7"? No. So your age does
I
not.
feel like.
Oh, go ahead.
I said I feel like they all are.
You feel like they all are what? Oh,
5'7". Coming from me being 6 foot,
No.
kind of like.
Ooh, wow. Brianna's very impressed that you're 6 foot.
What? How? What? I was.
Does your
I didn't
age
even grow that much.
Does your height determine your age? No. So they are not functions of each other. So we're going to consider this not a function. Just because you're a specific age doesn't mean you're a specific height. Just because you're a specific height doesn't mean you're a specific age. Well, I mean, obviously babies are little, but there's still different sized babies. Yes. Now, if a baby is 6 foot, then that would be a little bit weird. That would be very scary, actually. Okay. So I don't know if y'all got to this last year because obviously we left after the third 9 weeks, but did y'all talk about circles, like area circles at all?
Yes.
Ish. Okay. So when you have a circle, to find the area, this is the formula, pi r squared. I don't know if that looks familiar or not. But the radius of a circle determines how big the area is. So this would be considered a function because as the radius changes, you're going to get a different area. The same one radius can't give you multiple different sized areas. It's just this radius corresponds with this area. So that would be a function. Okay, letter C. DeMonte, you have an A. So do you know what percent that is automatically? No, why not? I need the thing. Okay, so A refers to what percentages? 90, 91, 92, 93, 94, 89.6 if your teacher's nice. So just because you have an A does not mean you know exactly what your percentage is, correct? Okay, but what if I told you you have an 87? That means you have a B no matter what, right? An 87 is going to relate to a B no matter what. But we're talking about if I give you a letter, does that mean you know what percent that's referring to? Not necessarily. So that would not be a function. Because it's not giving me just one specific answer. Okay, and the last one, I'm gonna have you sketch a picture before we answer if this is function or not. So a boy throws a tennis ball in the air and lets it fall to the ground. So when I say throw, I don't mean like straight up in the air. I mean like throw it. Like if you throw a ball, I just want you to show me the path of the ball, sketch what it would look like. If I threw a ball and it hit the ground. Draw it. I mean,
It
you can
depends on who's throwing the ball.
say again, Jackson.
It depends on who's throwing the ball, because some people
That's
like don't know how to throw.
Generally, if you throw a ball, what's the shape look like of
Do you
the
mean
path?
like I throw the ball or throw the air, an air? No, God. If do I draw the ball or do I draw like an arrow?
Draw a curve of like how the,
Okay.
it does not, I am the farthest from an artist, so it does not need to be anything special. Okay, so here's my dude. Okay, here's the tennis ball. Meh. Okay. Yours may be a little bit more flat, that's fine, but the important part is this a function, the curve of how the ball is thrown?
Yes.
Yes, because if I took my highlighter and I drew a bunch of vertical lines, I would never touch that curve more than once. So that would be a function. Thank you.
She's talking about her s-
Oh, I thought you were talking about mine. I would hate art. It's never been my thing. So no, I'm jealous of people that are good at it. Okay, so before we look at some graphs, we're gonna look at some vocabulary words real quick. So x-intercept. You don't have to know what it is. I'm just curious if anybody does. What? You're, okay, can you use more words than this? Intersect, I think.
I think x-intercept is something like that's like a independent variable.
It is an independent variable. You are right about that. But intercept, PT, not intersect. Intercept.
It's where the X goes down into the another grid, right?
You're
Thing.
getting there. Yes.
Yes.
Yeah. Yes. I'm gonna get a little bit better of a description though. It's whenever you're touching the x-axis. So here's a graph in case you need to know this is x, this is y. I'm assuming you know that. So if you don't, I might like jot it down. That's okay, Ian. Thank you. So the x-intercept is where the graph is crossing or touching the x-axis. So that would be somewhere like on the x-axis, like where that pink dot is. That's an x-intercept. And the coordinate of the y is always 0 because you haven't moved up or down on your graph. When you move coordinates, you go left or right and up or down. So what do you think the y-intercept is? Yeah, when we touch the y-axis, which would be like right there. So that's when your graph crosses the y-axis. And the x-coordinate is 0. Sometimes I'm going to ask for a solution, and that's when I'm asking about the x-intercept. So the x-intercept is also called a solution. Okay, so look at this graph. This graph represents the height in feet of a water balloon dropped from a 2-story window after a given number of seconds. So here's the water balloon. I throw it out the window. What happens down here? It doesn't die, but it does what? Hits the ground, right? Hits the ground. So first question, why isn't the graph keep going?
Because it stops.
Yeah. I don't care how strong you are not going to throw a water balloon through the ground without it popping, correct. We could go below the ground. Where could we go below the ground? Okay, where is negatives?
A hole.
A hole in the ground. Where else? Yeah, like water. Yeah, like the ocean is below the ground. Rivers, lakes, ponds, all those places are.
Wouldn't it just float in the water?
Well, yeah, but I'm saying thing, not necessarily a water balloon, but you could throw something under the ground
If you throw a water balloon at water hard enough, it'll pop. I know from experience.
Sweet. I'll try it out.
Please do.
Water, it'll pop. If you throw a water balloon into water, it will pop. I don't know. That's what Dean says. Okay, my other question is, why isn't the graph going over here? That I
That's
don't.
not where you threw it from.
I'm not worried about him throwing it backwards because that wouldn't be throwing it backwards.
What?
I'm worried about this.
I just threw it. Just.
It can't go that way because you threw it from a certain point.
Wouldn't it go into the negative x?
Who can time travel? Raise your hand. Oh, I wouldn't tell people if I could time travel. But you can't go to negative time. It is not possible. I can't throw the water balloon from -1 seconds. No, you can't, Gia. Huh? You can't. No, you can't. You cannot talk about negative time. So we are starting at 0. That's why it's starting at time 0, height 25. So, okay, so what is the x-intercept? So where does this touch the x-axis at? 1 point, well, what's right in the middle of 1 and 1.5? Okay, 1.25. That is not the answer. It's a point, x comma y. So it is 1.25, comma
0.250.
0. Good. I will tell you, this is one thing Miss Simpkins is psycho about. If you put 1.25, I will mark it wrong. 1.25 what? Chickens? Like you haven't taught, yes, you haven't told me the location. I need the location of the point. What? Okay. Well, no, but this time you can have 1.25 seconds. You can have 1.25 pounds of chicken. Yeah. So what about the y-intercept? It's up here. So don't say 25. What's the point? 0.25. Good. 0.25. Y'all are so smart. There are a couple questions on the next page about this graph, and I don't want you to have to like flip back and forth. So I'm going to leave the graph on my screen if you want to go ahead and flip over to the questions. And we'll talk about them together. But once you've answered those 2 questions, go ahead and flip the page. So the first question says, what does the y-intercept mean? I don't care that it's 0.25. For this situation, what is that talking about? What's happening at the y-intercept? The height of what? The height from where you threw the water balloon at. Correct. So the y-intercept is the height where I threw the water balloon from. Okay, so let's look at the second question, which says, what does the x-intercept represent? The time that it took to Hit the ground, correct. So the time it took to hit the ground or drop or however you want to word that. So the time it took the water balloon to hit the ground. What? It hit the ground after 1.25 seconds. That's what that means. The height would be 0 because it's on the ground, but the time was 1.25 seconds. And then just a little refresher. So solution is our x-intercept. So it is 1.25. And I would like you to use units. And the units for this were seconds. So I would like you to write 1.25 seconds for that solution. We are going to look at 2 more graphs, but I do want to talk about quickly these vocabulary words before we do that. I know there's like 4 more, I think, but we're only going to do those first 2. So domain and range should be reviewed. So domain is input or X values. Range is the opposite, so output or Y values. For increasing interval is as the X values increase, the Y values increase. And for decrease, as X values increase, Y values decrease.
Maybe it'd be decrease.
Nope, it would be increase. I'm getting there. It would be increase, decrease. The reason why is your X values, you're always looking from left to right, and the X values are increasing when you're moving from left to right, always. Okay, minimum, maximum, I'm not even filling in the blanks. We're just gonna draw a picture. So here's a graph. A maximum is like a hill. So wherever the graph makes a hill, for example, like this, the very, very top of that hill would be a maximum. If the graph does not change direction, so like a straight line, does a straight line create any sort of hill? No, it does not have a maximum. Graphs don't have to have maximums. It's only gonna have a maximum if it changes direction and turns to make some sort of hill looking thing. So minimum is like a valley. So if it looks like this bottom point of the graph would be the minimum. They don't have to have a maximum or minimum. They could have both. So let me show you a picture of what it would look like if there was both a maximum and a minimum. This would be a maximum, and this would be a minimum. So could have one or the other, could have both, depending on the graph. You don't need to write in the blanks. Okay, so let's look at a graph. This is an absolute value graph. Why do you think that that is what an absolute value graph looks like?
Maybe because it doesn't have any curves.
Okay, that's not necessarily why, but it doesn't. You're right. Yeah.
It's because the absolute value is if you switch it. Like
Okay.
-5 would be +5, and it's the exact same on both sides.
Okay, so if we are talking about the absolute value of -5, which is here, the answer would be +5, right?
Yeah.
The absolute value of +5 is also +5. So it does mirror, okay? So why is there no part of the graph down here? like in the third and fourth quadrant.
It's just repeating.
Yes. Because what? They are integers. You can take the absolute value of things that aren't integers though. So why would there be no graph like at the bottom?
Because there's no reason to.
Why not?
Oh, because that's absolute zero.
So the answer to all absolute value problems are what kind of numbers?
Positive.
Positives. So I can't get an answer to an absolute value graph, like absolute value question that's going to give me something that's negative. So that's why all of my y values on my y-axis are just positive numbers. I can take the absolute value of negative numbers, my answer can't be negative. So that's why the entire graph is above that x-axis are all positives or zero. I mean, technically you can take one at zero. What do these arrows mean?
Goes on forever.
Yeah, it keeps going forever and ever and ever. For how long? Infinity, right? Infinite. Words are hard. Infinity, infinite. So when we describe the domain, so domain is x's. It looks like this graph is going from -5 to +5, but it has arrows. So those arrows are telling me that this graph is going on forever, left and right, forever and ever and ever. So this is considered all real numbers, or you're used to writing it as infinity. I would prefer you to write this as all real numbers. So if I had this graph on the computer and I zoomed out, I could make the domain as big as I want to because it's going to keep going on forever. Now, domain, we were looking left and right. Range, we're looking up and down. Is this graph going up and down forever? It's going up forever. Is it going to go down forever? Where does it stop? It stops at 0. It stops right here. So we can't say all real numbers because the y values aren't -1, -2, -3, and so on. It's from 0 and everything bigger. So we're going to write that like y is greater than or equal to 0 because all of my y values in the graph are bigger than 0 or equal to. Okay, I'm going to skip increasing, decreasing just for a second. Does this graph have a maximum? So does it have a hill? It doesn't. It does not have a hill, so we're going to say no maximum. Does it have a valley or a minimum? It does. Where? At the bottom. What point is at the bottom? Say it. 0 is not a point.
0, 0.
0, 0 is a point. Correct. I just heard you say zzz. That's what I heard. Okay, so let me be honest. Increasing, decreasing is one of the more difficult concepts because it's not your fault, because your brain at your age right now is not developed enough to understand it. And it's literally like biologically, you just like can't. So I'm gonna do my best. And if you understand how I draw the picture of it, then I'm cool. But if you're confused about how to write it down here when we get there, don't worry about that. So look at the picture. I want you to take your finger and I want you to put it as far left on the graph as you can.
What if I'm just super advanced and just like get it?
Well, there you go. Sounds good.
All right.
So your finger should be right here. That's as far left as I can go on that line. I want you to trace that line down to the minimum. Just move your finger along the line until you get to the minimum. What direction did your finger move? Up or down? Down. Okay. So that means that this entire half of this graph until we get to the minimum, since we moved our finger down, was decreasing. Now, let me finish. I realize there's an arrow there that's pointing up. I don't care about that arrow. Which direction do you read in? I hope you read left to right, okay? So if we started as far left as possible and we were moving along this graph, it was heading down. Okay, now I want you to put your finger on the minimum. Keep tracing the graph to the end, all the way to the right. Which direction are you moving in? Up. So this half of the graph would be increasing. If that makes sense to you, then you should feel good, okay? Now I'm gonna show you how you should write it if I'm asking you about increasing, decreasing. So we're gonna use X, because remember, we're moving left to right. That's our X-axis, our horizontal. What point does it change direction? So what's the minimum? The minimum is 0, 0. So we're gonna use 0. And we're gonna use an inequality symbol to describe. So it's increasing on the right. What kind of numbers are on the right? The bigger numbers or the smaller numbers? Bigger. So we're gonna use a greater than. It's decreasing on the left. Which kind of numbers are over there? Smaller numbers. So we're gonna use the less than symbol. Okay, so on the right-hand side of the graph, it's increasing, so that's why we use the greater than. On the left-hand side of the graph, it's decreasing, so that's why we used a less than. Okay, all right, we're gonna do one more, and then I'm gonna have you guys practice looking at some graphs on your own, okay? So let's look at this graph. That was it, yeah, that was the hard thing. Okay, well, good, if it wasn't, that's cool. This is a parabola. This will be very important to you in about 2 months' time, but not right now, but just for funsies, it's a parabola. Yeah, sure, if we get there in March, April sometime. Yeah, we do, unfortunately. So again, we have our arrows. This time the arrows are pointing down, but they're still pointing out. So what does that mean? It's going on infinitely. So our domain is all real numbers. So left and right, it's going to end up going forever. What about up and down? Does it go forever up and down?
Yes.
No, ma'am.
No, it does not. It goes down forever. It stops right there. Every piece of that graph is below 0. So y is not greater than, it's less than or equal to 0. All of our y values are smaller than 0. -1, -2, -3, -4. So they're all smaller than 0. Okay, we're gonna go back to increasing and decreasing in a second. So does this graph have a maximum? Does it have a hill?
Yes.
It does. What point is the maximum?
0, 0.
0, 0. Does it have a valley or a minimum?
No.
No, so we're gonna say none. Okay, so take your finger, put it as far left on the graph as you can. Should be right here is where we're starting. So start tracing it. How are you moving? Up. So up to the maximum, this whole side is going up, which would be increasing. So once you touch the maximum, what happens?
It stops.
Okay, and then keep going,
Goes down.
going down. So this half of the graph, the right half, is decreasing. So if we're to write that, remember we're using X. Where does it change direction? At 0, good. It is increasing on the left. What kind of numbers are on the left? Smaller numbers, so we want to use a less than. It's decreasing on the right, and that's where the bigger numbers are, so we want to use a greater than for decreasing.